All right, welcome back. So today we're going to be talking about reference table M. So if you could go make sure you have table M available, it's on page 6, common acid-base indicators. So there are a few different ways we can measure pH. One of them is with pH paper. So you might be familiar with this from if you have a pool or maybe a fish tank. You take a sample and then you place a drop onto the paper itself and you see what color it turns and you compare it with the chart. It's important not to dip the strip into your sample because the strip itself has chemicals on it and you don't want to damage your sample. So you would just take a drop of your sample and place it onto the strip of paper. That obviously is open to interpretation. Some people have trouble differentiating colors. So you can be a little bit more up to date, even though this is actually kind of an older model. With a pH meter, it's a machine and it will measure the pH. There's another way, which is different chemical indicators that are specific to certain pH ranges, so better in some ranges than others. For example, this is something called the universal indicator. Notice that normally it starts off green. Green would be in the neutral range. If you take universal indicator and add it to a substance that's an acid, depending on how strong of an acid, it's going to turn either yellow, orange, or red. If you add it to a stronger base, it's going to be higher on the rainbow Ricci-Biv scale, so that's kind of cool. If you're looking on table M, you can see we have other indicators. So these indicators are going to change color within 2 pH units at 25 degrees Celsius for a specific range. So on table M, you've got 6 of them, and you notice that they have an approximate pH range where the change will occur, and then it'll show you on the rightmost column what the color change is. Here's how to read this chart. If you're given a certain pH and it's below the first number in the pH range, the value listed on the left, your color will be whatever is the leftmost color in the color change column. For example, I'm looking at methyl orange. Let's say I have methyl orange in a substance with a pH of 2. So if I look at methyl orange, 2 is below the range here. See how it's below this range? So that means it's going to be the color on the left, which would be red. Okay? If the pH is above the value listed on the color change chart, it's going to be the color on the right. So let's say I'm using methyl orange again in a pH 6. So if I notice, again, the range is 3.1 to 4.4, and my substance is a pH of 6, that's over here, so it's going to be the color on the right, which is going to be yellow. But what if the pH is in between these values? Well, you might be able to say, well, it's between red and yellow, so it's got to be orange. But is it more red? Is it more yellow? What is it? So if the pH falls in the middle of the range, the color is unknown. You can just say unknown or undetermined. You would determine it if you were in the lab, but looking at it from a piece of paper, you can't tell. So here's table M. So bromethymol blue, 6.0 to 7.6. Oh, looks like it changed. 7.6. All right. So anything below here is going to be what color? Bromethymol blue below 6. It's going to be yellow. Any pH higher than 7.6 is going to be blue. And what about in the middle? We can't tell from a piece of paper. There you go. That's pretty much how you use table M. Thanks very much.